Morning, everyone.
Yes, you heard that.
Hi.
Look, bro, I
Friendly reminder to make sure that your phones
Hey.
and earbuds are put away in your pockets.
Or change. He's changed this one.
That's going to be obviously for the duration of the hour, so that way you can pay attention.
today.
As you are getting your notebook out to continue our notes,
I lost my folder.
we are looking to be on track to finish this today, which means then that way tomorrow we can actually go on the shop and demo the lab. You can choose your lab partners for this unit, and we might even get a little bit of time to start working on that. Worst case scenario, Wednesday should be a full lab day, and we're probably gonna have scheduled out 2.5 weeks roughly to get this particular lab completed. We'll see if we need more time or less time based off of that, and then we'll have a test. At some point in time this week, you will have the study guide for the assessment for this stuff. More details for that to come obviously later on. But for this week, starting today and due this Friday, another 4-day lesson, tire dimensions. Again, that should be a little bit of review of some information that we've talked about previously, but it is also going to be able to get into maybe some additional things that we didn't talk about, which may show up on a test or on our test. So that's the only assignment as of right now for this week. But again, more to follow with the study guide. Okay. I'm trying to think of anything else crazy. I did get the grade book caught up this weekend, so if you go into Skyward, you can kind of see a good representation of what you're at for third quarter. If you did not get any of the previously assigned Ford ACE lesson quizzes completed, I would encourage you to still do that.
I didn't do it.
Get that submitted, and I'll get to that at some point in time here and in the grade book. All right. But at some point in time, those will be shut down, most likely towards the end of the units when we take our assessment. At that point in time, you'll no longer be able to submit anything or potentially earn points towards that. So again, I just want to make that abundantly clear to everyone.
Oh, remember when investigations had to put the backpack?
Yeah, that way I can see what you guys are doing. That can go in your pocket. Thank you. Okay, don't know why we got our Chromebooks out either. Not really needing those things. Oh, what do we got at the door? There it is. Alright, previously we've talked about the 3 wheel alignment angles. Caster, camber, toe. These 3 are going to be your bread and butter when it comes to trying to figure out getting everything in alignment, right? Everything going in the same direction.
Not doing that no more.
Fun thing about that Easton is he's got to make his own decisions at some point in time.
Yeah.
So
I kinda get
doesn't bother me at all.
So I can keep playing my game?
No. No.
Oh, you
Because
said-
I have higher expectations for you, Easton.
Oh, alright.
Thanks.
Alright, anyways. Caster, camber, toe. That's your bread and butter. When we go out to the alignment check, you're going to be running numbers on caster, camber, and toe. Even though caster is not something that we would typically adjust, unless we had aftermarket stuff that usually is set from the factory, but it's still good to know what the caster is, as you're going to find out here a little bit later, because that can dictate some issues with the car if those angles have changed. We focused in on camber and toe. We talked about how we can adjust those. Typically camber is adjusted through the movement of the lower control arm in most cases. shifting that back and forth, which changes the degrees of the inward and outward top tilt of the tire. Toe is typically adjusted through the outer tie rod, which is going to be linked up with our steering system, which then obviously dictates how forward facing the tire is as it's rolling down the road. The alignment angles that we're going to be talking about today are kind of secondary wheel alignment angles. These are typically not something that you would directly change or have influence, but it is something that we can use to diagnose issues with the vehicle. Okay, so those three angles are thrust angle, steering axis inclination, which is something that we've already kind of briefly talked about at the beginning, SAI, and then toe out on turns. Okay, those are our three diagnostic angles. So when we do our when we do our alignment check, our machine is going to be checking for those along with caster, camber, and toe. But again, it's not something that I can fiddle with on the car to change these things. Okay, there we go. Okay, so again, we're going to go one by one through these to kind of discuss what they are, how they impact the alignment, why you want to obviously understand what's going on. And again, I want to just put the context in here. We are talking exclusively about like your standard automobiles, trucks, cars, something that you're going to encounter while driving on the road. We're not going to get into more than 2-axle vehicles. We're not going to talk about 18-wheelers because that is a whole can of worms that you don't need to know right now. We need to first find out the fundamentals about this stuff, and then if you are interested in pursuing a career or information about big rigs or commercial vehicles, you can pursue that on your own or after high school. Anyways, thrust angle. Another vocabulary word here that I'll underline. Okay, what is thrust angle? It's an imaginary line, just like your imaginary friend, that is drawn perpendicular from the center line of the rear axle down the center line of the vehicle. I'm just kidding about the imaginary friends.
I have a question. Why do you underline it if you're just going to underline the whole thing?
So that way I understand that you understand it's important.
Take this up.
Okay, fine, well,
It's the whole thing.
there you go.
I think it's right.
I fixed it.
Just do imaginary line, center line of the vehicle.
Yeah. Yeah. So again, what is the definition of alignment? Take a look at your notes. What do we say alignment was? Chris? Straightened? Positioning in a straight line? Yep. Okay. So that means everything, not just the front wheels that are doing the turning and the steering. Okay. We're also interested in making sure that the rear wheels are following the front wheels as well. So again, if your wheels, I'm just going to draw this on the image because it's not here. And again, this is over exaggerated. But if these rear wheels are off-center, okay, basically what you're doing is you're saying the car, when I'm spinning these wheels, wants to go this direction, even though the front wheels want to go straight. Okay, that's going to cause some issues. Okay, it's going to cause these wheels in the back to start scrubbing at a very odd angle. Now, some people might say, oh, hey, your toe is out on your rear wheels. But again, we have to understand that thrusting is a little different. We're not necessarily talking about toe. It's your axle that is changing your thrust angle. Okay? Now, here's kind of a weird question. You might know this answer, you might not. What would cause the rear axle to be misaligned with the rest of the vehicle? What do you think? Excessive jumping. Maybe. That's obviously not the only thing that could potentially do that. What could cause my rear axle to be out of alignment?
Like sliding around.
Sliding around?
A loose bolt.
Loose bolts?
Rust.
Rust, okay?
A rusted out like frame on the bottom.
Yep.
Maybe.
Me, baby, baby.
Thank you, Chase, for that rendition of
You like that?
that Mariah Carey song.
You like that?
No? Okay. Tyler's still waking up. Ever been rear-ended before?
No.
You ever seen somebody get rear-ended?
Yes.
Any kind of car accidents?
Yes.
Right? Hey, I'm driving and all of a sudden, no, where did that speed bump come from? All those things here are going to physically change the mounting points of where that axle is on the vehicle. And that's most likely going to change our thrust angle, okay? So, when I go on my alignment machine, and I'm doing caster, camber, and tow, it's gonna tell me, hey, is my thrust angle? Do I have a positive or negative thrust angle? Well, if it's anything but neutral, it's probably a clear indication that that vehicle may have been in an accident. Something has caused that to shift, and there's no way to necessarily adjust it outside of the chassis, right? How it's bolted to the chassis, which means the chassis is probably twisted. So it's something to keep in consideration, right? At some point in time, I might actually be doing a wheel alignment. I might be trying to do everything I can with caster, camber, and tow, but if the car chassis is bent, there might be a very good amount of limitations that I can do to get this thing to actually be aligned. There might be some additional things that are on the table, adjustments that I'm going to need to end up doing that are going to be just way too costly for the customer to want to complete. Okay, at that point in time, I might have to just let them know, I can't align your vehicle. Okay, it's been too far gone, if you will. Okay, so just something to keep in mind. Again, I do want you to let be able to identify. Right, this main center part, that's 0 degrees. That is our neutral line. This is what we want the vehicle to be going in. Everything in alignment with that center imaginary line that's drawn perpendicular to our axles. Okay, that's the whole idea behind that. Now this is kind of the fun part, right? Well, apparently we're in a British car, something with right-hand steering. But if we're looking at going this way, anything up here is positive, anything down here would be a negative angle. Okay? And again, everything that we should see on our thrust angle is going to be neutral. It should be 0. Yeah, if I have a thrust angle that's
The one right there is negative.
yes. That's positive, that's negative.
So the driver's side is negative.
Yes. Alright, again, the purpose of the thrust angle is to determine if the rear axle is lined up, right, alignment with the center of the vehicle as well as the front axle. Now again, I told you I'm not going to be getting into this, but you could very clearly understand, maybe comprehension wise, if I had an 18-wheeler, how many axles do I have in the back? 2, right? So obviously there's some additional steps and angles and mathematics that are involved with the thrust angle on my semi-truck because I got 2 axles instead of just 1. Okay, it's a little bit more finicky. Okay, so when we go to do alignment on those type of vehicles, that is a very, very critical step. Especially when you consider the cost of tires on an 18-wheeler. And how many miles they typically drive on the road. Okay. So anyways, that's kind of our main concept between thrust angle. Okay. And again, rear wheel drive, I'm thrusting the vehicle forward. Front wheel drive, I'm pulling it forward, but these are still following. I want to make sure that that's there. Otherwise, if these are off, okay, how is that going to change the handling of your vehicle? Okay, especially in winter conditions, right? If I'm driving, your rear end is probably going to want to slip out a little bit more often. A little bit harder to control, harder to protect, harder handling. Okay, and again, we want to make sure we have this note in our notes, right, Chris?
Yeah.
What you watching now?
The notes.
Oh, okay, cool. Why don't you put your backpack on the ground? appreciate your subtleness of trying to do that. Alright, a vehicle will pull away from the thrust angle, which means if I have negative thrust angle, it's going to pull to the right. If I have positive thrust angle, I'm going to pull to the left. If I'm driving the vehicle, right, if I'm an auto tech and my customer is complaining about their vehicle pulling to the left or right, I want to emphasize that there's a lot of things that could cause that.
Maybe positive or
Okay. 1 second, Chase.
It's on the board.
Okay,
Yeah.
there's a lot of things that can cause my vehicle to pull. If I'm driving down the road, I expect my vehicle to go straight down the road, then I'm pointing the direction in the car. If I were to theoretically let go of that steering wheel and I'm starting to pull left or right, one of the factors could be my thrust angle. Okay, again, negative thrust angle pulls to the right, positive thrust angle pulls to the left. Is opposite, or I should say it pulls away from the thrust angle. But again, thrust angle could also be an indication of camber, could be a caster issue, could be a toe issue, could be a braking issue. Again, it depends on when that pull is happening. Yeah.
So when is thrust like tuned compared to caster, camber, and toe?
It's not. It's not. Typically speaking, right, like caster, it's not adjustable. Okay? So it comes from the factory, it's set, everything's properly tuned in that case. When I go to do an alignment check, or an alignment on a vehicle, I am still checking the thrust angle, because that's going to let me know, hey, maybe this vehicle has run off a jump, right? Maybe it's hit the curb a few more times than I might have known about it, what the customer knew about it. Perhaps maybe this has been in an accident, okay? So that's going to dictate and change how I might align my other angles that I can influence, camber and caster and toe, well, camber and toe typically, okay? But it's just something to denote. Again, if it's too severe, you might just say, I'm washing my hands of this, I can't perform this with a guarantee that I'm going to be able to get it right for the customer, because if I touch it and I try to start making adjustments and I give it back to the car saying this is now aligned, but then they still have issues with it, guess who they're going to blame? You. Right? The person who's trying to do the alignment. But if you come back to them and say, I can't do this because X, Y, or Z, right? They might be still upset at you, but now all of a sudden you're not liable for that. Okay. Tracking, again, this is another vocab word here. Boom, tracking refers to the position or direction of the two front wheels in relationship to the rear wheels. How do they track? Once I kind of explain this a little bit more, it'll probably make more sense of why we call it tracking, or what exactly this tracking is. Do you ever see that the Hummer commercial? I think it's a newer Hummer commercial where it's like all of a sudden they're like, oh, it's a Humvee, and then all of a sudden like the vehicle's pointing in this direction, but then it's like going like this, right? Yeah, crab walks. That's the technical name for it. It was funny because like I was watching TV and my kids were watching it with me, or my son was, and he's all like, "What's the purpose of that? Like, why would you want to do a crab walk?" And I was trying to explain it to him like,
mechanical failure.
it's
It
kind
can
of
also get you out of
That sounds like a lot of mechanical failures.
well, it's on purpose. But what they end up doing is actually like steering with the front and rear wheels, and they point it in
Well, they steer the same.
an
Each other,
odd
yeah.
direction, right?
Yeah.
So that way you can still face forward, but you're as you are thrusting forward, you're actually going forward and sideways. You're going diagonal. Okay. And I'm like, you know, this is a larger vehicle. Sometimes larger vehicles have difficult times maneuvering in tight places. That's kind of one of their biggest complaints. So what they end up doing is General Motors is like, well, let's put this system in place, and then that way you can like get in and out of parking spots maybe a little easier, or maneuver things around.
One of our
Okay.
work trucks has like rear-wheel drive that you can just flick on.
Say that again. What
One
vehicles?
of our work trucks
Oh,
As
yeah.
You can just flip it, it's just a switch.
Yep.
You can flip it on, so it's rear wheel steering also.
Yeah.
It's so fun. And it's a 360-degree radius.
Porsche's gonna have a system like that as well.
Like a G, right?
So typically,
No, like a
it's
zero
fun
turn.
because if you've ever driven in a vehicle with rear wheel steering, it almost feels like your rear end is
Pretty much,
actually
that's
kind
it.
of kicking out on it.
Like you have a zero.
So it takes a little bit to get used to, but fire trucks have it as well,
That's mine.
Really?
right, Easton?
Yeah.
Okay. Fire trucks have it because again, fire trucks are really long.
Yes.
Okay, so again, if I gotta make a very sharp turn, right, and I gotta avoid vehicles, I need to make sure that I can steer with my front and rear wheels. That's gonna potentially change the dynamics of that. Okay, tracking. You ever been in the snow before? I'm gonna presume yes, because we live in Wisconsin. Have you ever did that? I know you've done
Did you
this.
see the groundhog didn't see a shadow?
Thank you, Chase.
What?
You ever walk in snow and you're like, I'm gonna make steps, right?
Then spring comes.
And then all of a sudden you get out to where you're at, you turn around and you go, oh man, I gotta walk back. And then you were like, you know what, I'm gonna step in my same steps that I did, so that way people don't know I did it back. And you were stepping your same steps, and they're like, ha ha! I tricked them, they're gonna follow my steps, but then I double backed. You ever do that?
Yeah, mine takes a
yeah, right?
I've actually done
Okay,
that once.
that's tracking.
Perfectly.
Basically what's happened is the front wheels, as you're driving, makes tracks in the snow or on the road. You want the rear wheels to basically follow in the same tracks as it's moving forward, okay? You don't want it to be like, hey, the rear wheels are making separate tracks than the front wheels. That would mean a misalignment, okay?
I just plow everything
So,
in front of me.
just something to keep in mind. If you ever are driving in the snow and you notice that about your vehicle, maybe you can ask yourselves questions. Hey, we learned about tracking. Maybe I have bad thrust angle on my vehicle. I might want to go take a look at that. Which could explain why my vehicle's always pulling left or the right.
Yeah.
Who knows?
Does your vehicle pull to the left or to the right?
No, it has good tracking.
Are we sure?
I'm sure, yes.
Does your windshield look in one piece or multiple
It
pieces?
is currently in one piece.
Does your car know about this?
No, because it's not alive.
Are you sure?
Where is it?
Where is it?
What? That's such a weird thing
How
to
old is
ask
it?
me. Alright,
How old is
turning
it?
angle, also known as toe out on turns. We've talked about toe in and toe out. We know what toe is, okay? But this is kind of another step forward. It's called toe out on turns. And this is a little bit maybe a more interesting thing to talk about and understand in regards to what is actually happening as you are turning your vehicle. Because there's a lot of cool geometry that happens. But toe out on turns, all it is, your turning angle. It describes the difference in side-to-side steer angles of the front wheels as the vehicle turns. Okay, so think about it like this. If I'm turning my wheels and I want to turn the vehicle, what is really taking place?
Your turn.
You're literally rotating the car. Okay, so I have a radius. That radius is a circle. That radius is going to have a center point that we need to rotate around. Okay, if I were to draw a line going through my rear axle out to infinity,
You stopped at the other.
and then I take my two front wheels and I were to draw, again, an imaginary line through the center axle of each wheel,
Out to infinity.
okay, what that's going to mean is these are going to all intersect at one point, which the vehicle then is going to rotate around into basically one giant big circle. Okay, it's a turning radius.
Then you got an e-brake into that.
Now, the cool part about this is, again, a lot of vehicle manufacturers want a smaller turn radius. Okay, if I have a small car, I have a smaller turn radius just because my axles are not as far apart. Okay, I can turn the wheel harder and I can rotate a tighter radius. Okay, if I have a big long pickup truck, it's like 14, 18 feet long, okay, the wheelbase, or how far apart the wheels are, or the axles on those wheels, Okay, which means now I have a larger turn radius. I can't get around as nimbly as something that's smaller. Okay? Think of it like this. You ever seen a marching band before?
Yes.
Okay? As a marching band, we're marching down the road, we're all in rows, we're all marching at the same time, right? But then, I've got to make a corner up here to get onto a different road to follow the parade. Well, what's going to happen to all the people that are closer to the radius, gentlemen? Right? I gotta turn around right here. Here's my line of band members. What do these people that are standing here have to do in comparison to the people that are standing here have to do?
People on the outside move slower.
Opposite of that. Okay, if I think about this for a second, the people that are closer to the center of this radius,
They have a less way to go.
okay, they have less distance to cover. The people over here have a greater distance to cover. They have to go faster or slower to cover that same distance in the same, or the larger distance in the same time.
Faster.
Much faster. Okay, so they're doing one of these things, right? To get around the room much faster. Okay?
They're cutting in.
The people on the inside, though, they're kind of really dorky because they're taking like super small steps. Right? 'Cause they don't have to cover as much distance, they can go much slower. Okay? The same concept is true with our wheels. Okay? If I'm making a radius turn, right, that inside wheel is turning at a lesser speed than my outside wheels. Okay? If these two tires were at the same angle, parallel to one another, they would never intersect that at the same point in time. My wheels would actually be scrubbing, which causes issues.
How does a diff lock work?
Okay? We're not talking about diffs or diff locks, but differentials are going to have similar issues with this.
Well, I
Or should I
noticed
say
that-
similarities in regards to this. So, as I go to check my wheel alignment, I do want to check my toe, okay? But then I'm also going to manually turn my wheels because I want to see the differences in the angle and make sure that my toe out on turn, a diagnostic angle, is going to be able to match up so that way I can obviously have the best turning radius. Okay?
Stop rubbing on me. Stop.
Again, created by the angle of the steering arms. Turning angle allows the outside wheel on a turn to steer at a lesser angle than the inner wheel. And again, all we're trying to do is make that intersection as close to the vehicle as possible so I don't have to go as far a distance. Okay? And this steering arm, typically speaking, is attached to our steering knuckle, and it's a solid piece of metal that you can't adjust. Unless
You heat it up and reload.
you modify the steering knuckle. You get an aftermarket part. Hey, I want to go drifting. Right?
Just go drift.
Just go drift. Unfortunately, in order to be able to drift, when I turn my wheel, the front tires aren't going to have enough turning angle to be able to allow or accommodate for the rear end clipping out and for me to catch it and to maintain that as I'm making my turn.
That makes sense.
So a lot of these drift cars are going to modify their toe out on turn by modifying their steering arm. Okay? They have to extend it out further. So that way when they turn, it doesn't just go like, you know, the standard amount, but we can actually almost kind of lock these things sideways, which is something you normally wouldn't want to do, obviously, as you're driving down. We don't need that tight of a turning radius.
But you got a monster truck.
Yes, something that you totally could drive on the road.
You should start with that.
Alright, steering axis inclination. SAI, as I'm going to put it for the rest of the presentation because it just takes too long to read or to say. Okay, SAI, fun fact, is represented by that symbol right there.
What that mean? What did I do?
Okay?
What that mean?
And the steering axis inclination. It's a Greek letter.
Equals 0.
Oh.
No, it does not equal 0. It is not 0. Okay? SAI is defined as the angle measured in the front elevation between the steering axis and true vertical.
Cussing. I was showing him most of Chuck's work. I was like, yeah, you know most of Chuck's work.
Okay. Caster, camber, toe. Caster is the wheel alignment angle that we are measuring when we're looking at what direction on the vehicle. What angle am I looking at the car when I'm trying to measure or see caster? Simon?
Side.
The side. Okay. When I'm looking for camber, which direction am I looking at the car?
Front.
The front. Okay. SAI is essentially going to be the caster angle, but when we're looking at the front. That's the best way I can describe this, okay? So, here's the center point of my axis for my wheel. Here's the mounting point for my strut, okay? Again, my tire is straight up and down, okay? This going from here, basically through here, oh, I didn't draw that, okay, through the center axle, is going to be at an angle.
Pull it up.
So this is straight up and down. There's an angle here. That's SAI. But again, I'm looking at it from the front. Okay? Important to understand the definition of SAI. Angle measured in the front elevation. I'm looking at the front between the steering axis, okay, and true vertical. So that distance right there. So my caster is a step back from the side, but then when I look at it from the front, I also have a secondary angle that I'm looking at. The secondary axle or angle that I'm looking at is the SAI. Okay? So from this angle, caster, this angle, SAI. Alright. Now, another big key thing here that you're going to want to make sure you get in your notes. SAI gives directional stability, much like caster does. That's cool. It is non-adjustable, just like caster. Only changes when the parts are bent.
Very important for you to check in collision.
Yes, very important when we're checking collision work.
Give it back now.
So if my SAI is set at a particular degree from the factory, I go to do my alignment check and I notice that the SAI angle is different. What is that telling you?
It's been in an accident or some sort of.
Something has been bent.
Something's been.
Because guess where this mounts to in my vehicle?
Your chassis.
My strut tower, okay, which is part of my chassis of the vehicle, the body of the vehicle. So the only way that this angle changes, right, either this gets greater or lesser, is if this strut tower is bent. It's changed. The only way that chassis changes is if it's been hit. Okay? Very important to know that. So how in the world then do I readjust my steering axis inclination? Well, you're going to be talking to somebody who can do body work, who might be able to rebend that back to factory settings. That is a very, very time-consuming, labor-intensive,
And
very expensive
expensive.
equipment to be able to do that. Okay? Your insurance company might say, you know what, instead of spending $10,000 on your $2,000 car to fix it, we're just
Spend
gonna junk
$400.
it. That's typically what would happen, okay, because it's been in an accident. It's also kind of fun, hey, I'm looking to go buy a vehicle, awesome. Before you put money down on that vehicle, you're gonna wanna probably bring that vehicle to a licensed technician who knows what they're doing, who you trust. Say, hey, can I get an inspection on this vehicle before I buy it? More often than not, they would absolutely love to do that for you because then they can tell you what's going on. Hey, Facebook Marketplace, $1,000. No lowball offers, I know what I got. Do you though?
No.
Right?
What the hell are you selling for $1,000?
One of the things they might actually end up doing, that technician, is actually do an alignment check on it. They throw it up on their machine, they do an alignment check, takes probably about 10 minutes on a trained technician, and they can tell you SAI, thrust angle, toe out on turn. Again, not something that they would normally adjust, but it's an indication if those numbers are off, if the car's been in an accident, and the person who's trying to sell you that vehicle is lying to you.
Yansky, what do you think the cheapest car you can buy?
Okay.
Doesn't matter.
Civic.
That's kind of how that works.
About 100, you got it.
Think so?
Alright, major parts are bent and need replacement if either the SAI or the toe out and turns is incorrect. And again, how do I know?
Just a question.
How do I know if it's incorrect? The manufacturer who built the vehicle
I'll tell you.
knows what those are. They've mathematically calculated it out. They know the mounting points. They know all of that technicality stuff on the vehicle. They've published that information. Okay? Now again, you could manually go in and measure all of these factors. Okay, but it's very time consuming. You're going to be using a lot of string and protractors, plumb bobs, okay, tape measures. And you could do it manually. It would just take you a half a day to do it. Or if you do it often enough, you can buy an $18,000 to $20,000 piece of equipment, slap some targets on there, allow the computer to tell you what to do, boom, 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 and then it can mathematically calculate that stuff throughout like trigonometry and calculus. Okay? So all your math classes that you were in high school, and you're like learning how to do all these like equations, sine, cosine, tangent, right? Slope, like all that sort of stuff. Even your, I don't know if you guys have gotten into this, but like ovals and ellipses. Have you done ovals and ellipses yet?
No.
No? Okay. All that stuff can be fed back into a computer or can manually be calculated to figure out these angles. And then you can compare the two to one another. Hey, this is supposed to be 1.2 degrees, it's 1.4 degrees. And then you now have been trained to understand that if any of these are off, okay, thrust angle, SAI, or toe on turns, number one culprit, bent chassis. Something's broken. And again, we'll get more into this later on when we get into suspension components, okay? But there's a lot, these are all suspension and steering components that are going to influence and impact our wheel alignments. And obviously we can go in here, we can adjust these. Some of these we can adjust, some of them we can't. To do camber and toe. Awesome. All right, any other thoughts or questions?
Nope. Can I go home?
Yes. Yes, you can. I give you permission. However, attendants might not see the same thing. All right, I'm going to end the presentation here.
Levi, what do you want for your truck?